So, let us have some interactive problem solving sessions by students who have taken this course. So, you will see some illustrations and examples into problem solving which is useful to understand and digest the concepts learnt during the lectures.
Okay, hello everyone. I am Ankur. We are going to solve this problem which appeared in the MMTSP 2013 IISc course in exam 2. The question is, simplify the multirate systems shown in figure below as best as you can. Obtain the frequency response y of z in terms of x of z. So, there are two parts, A part and B part. We have this signal x of n and it is going through some upsamplers and downsamplers, and we have to get the frequency response y of z in terms of x of z. Now, if you carefully see, we have some upsamplers and downsamplers, and we wish to have a very simplified form. Now, to go about the solution, what we will do is, we will split this downsampler which is downsampling by a factor of 20 as downsampler by 5 followed by downsample by 2 followed by downsample by 2. So, because 5 into 2 into 2 is 20, that is why we will do this and hope to see what happens next, because we have this upsampler 5 and we would like to undo what the upsampler does by having a downsampler 5. So, if we proceed in this direction, we have what we will get is this upsampler 2 followed by this upsampler 5 which is given. Now, when we substitute this downsampler in this following way, so this is just the substitution of the downsampler 20, and then we have an upsampler, and then we have y of n. So, now we see here what is happening is this particular block is basically identity. So, this is going whatever the upsampler does, the downsampler is going to undo it. So, next what we get is, simplifying further, we have the upsampler by a factor of 2, and then we have 2 downsamplers, then we have the upsampler 2, and then we have y of n. Now, if you carefully see, this factor is also identity. The upsampling by 2 and followed by a downsampling by 2 is again identity. So, this again simplifies our work and we get downsample by 2 followed by upsample by 2 followed by y of n. So, the key thing to note here is upsampling by a factor of m followed by downsampling by a factor of m is an identity. However, the reverse is not true, that is, the downsampling by factor of 2 followed by upsampling by a factor of 2 does not lead to identity. So, if we do the simplification of this, if we write this signal as some v of n, what we get is v of z is going to be half of x of z power half plus x of minus z power half, and y of z is going to be v of z square, which is equal to half of x of z plus x of minus z. So, in this way we have got this simplified version of y of z in terms of the z transforms of the signal x of n. So, the initial block which looked very big, this block has been reduced to a very simple form, and thus we are able to get a simplified form of y of z. Now continuing with the part B of the question. We have this block, we will write it again for convenience, x of n followed by an upsampler, and then we have a filter z power minus 3, then we have a downsampler followed by an upsampler followed by a filter z power 3 followed by a downsampler of factor 5 and y of n. Now we know we have to use the Nobel identities here because we have filters here and followed by upsampler and followed by upsamplers, downsamplers, all these combinations are there. So this block, this block we are going to simplify as follows. So z power minus 3 we will write it as z power minus 5 times we write it again. So z power minus 3 we will write it as z power minus 5 times z square. So in this way we can take the z power minus 5 to the left hand side of the upsampler and do some manipulations as we did in the previous example with the upsampler followed by downsamplers. And similarly this block we want the downsampler to come this side, we push the filter to the right side using the Nobel identities. We will use z cube equal to z power minus 2 times z power 5. So using these two relations we will push the upsampler and downsampler inside and take the filters to the other side. So what we get here is upsample by a factor of 5, and this we write it as z power minus 5 followed by z square followed by downsample by a factor of 2 followed by upsampler by a factor of 2, and then we write here z power minus 2 z power 5, and then we have a downsample by a factor of 5 and we have y of n. So this simplifies to, using the Nobel identities, we get z power minus 1 and we have a factor of 5 here, and we have z square, we have a factor of 2, we have an upsampler by a factor of 2, and we have z power minus 2, and we push this downsampler inside and we have z. We see some form of symmetry here. We have z power minus 1 and we have z here, and we have z power 2 here and z power minus 2. So something seems to be symmetric and we go forward in this direction. So we get z power minus 1 followed by an upsampler by a factor of 5. Now if we see this block, we can use the Nobel identities and further simplify it to downsample by 2, and this becomes z and this becomes z minus 1 followed by an upsample by a factor of 2 followed by a downsample factor of 5, and we have z and we have y of n. So if we see here, these two are going to be identity, z followed by z power minus 1 is basically identity, and then we have if we simplify further, we get z power minus 1 followed by a factor of 5. So, if we see here, we are going to get a downsampler by a factor of 2 here, and we have a downsampler by a factor of 2 here, upsampler by a factor of 2, and we have a downsampler by a factor of 5. So, we want the we want to interchange these two and these two, so that the upsampler by 5 gets nulled by this downsampler by 5. So, if we proceed in this direction, we interchange these two because their GCD is 1, they are co-prime. So, we can interchange them. So, we put a downsample by a factor of 2 and upsample by a factor of 5, and this becomes 1, and then we have the interchanging of these two, downsample by a factor of 5 followed by upsample by a factor of 2, and then we have the regular filter and y of n. So, these two are going to be identity together, and what we have next is x of n followed by z power minus 1 followed by a factor of downsample by a factor of 2 and upsample by a factor of 2 followed by z and then y of n. Now, this can be simplified. I think this is the most simplified form, and if we go further and write this as some v of n, what we have is v of z is basically z power minus 1 v x of z and if we write this as some r of z, what we have from previous example, we had this kind of a downsample followed by an upsampler. So, we have r of z from previous result, we have it equal to half of v of z plus v of minus z. Simplifies to half of z power minus 1 x of z plus, now we have wherever there is z we have to put minus z. So, we get minus z power minus 1 x of minus z. So, this is equal to half of z power minus 1 x of z minus z power minus 1 x of minus z. So, this is r of z, but y of z is basically, so this is equal to half of, we multiply it with z, which is z power minus 1 x of z minus z power minus 1 x of minus z, and the z cancels the factors which are multiplying x of z and x of minus z. So, what we have is x of z minus x of minus z. So, just the two examples that we saw, one we had a factor of x of z plus x of minus z, and here we have x of z minus x of minus z.